All right, we left off. The last thing we were talking about was histograms. Okay, that was that program he made. They would do that. But the next section is about searching an array. Now, the whole stuff here we're talking about is not really something special. It's just his way of showing you how you could do something. Okay, so it's often need to determine whether an array contains a value. Here's pseudocode that could be used to do it, and it's called a sequential search. What does sequential search mean? Anybody know?
Sequential in order.
That's sequential. In other words, look at the first one, then look at the second. Was that the best way of doing things?
No.
Probably not. It's probably one of the worst ways, but it works. Okay. So basically, pseudocode says set I to 0, while I is less than the number of filled elements. In other words, well, we're still looking at items. If it equals the value, do something. If not, increment. So basically, we're going to look at each item. Okay. Okay. If we do find it, stop searching. You know that saying, you always find it at the last place you look? Or something like that. Well, the whole point is the reason it's the last place you look is because you stop searching after that. Why continue to search? It'd be...
Why everything's always where you left it.
Exactly. Yes. All right. So, problem descriptions. Write a helper method that finds student and searches for an ID value within an array of student IDs. The method should receive an ID parameter and return the index of it. Okay. As always, use appropriate values. We don't actually have them. I'm not going to go through and write these, but what you could do is, it's kind of like student IDs. Okay. We could pass it an ID, and it's just going to go through the array item by item until it finds it. Okay. Now, Java, with something that's not really covered in here, Java has a whole bunch of functionality for sorting and searching and all that's built right into it. Okay. But before you can search, it really needs to be sorted. Okay. It's kind of like, can you imagine looking through a phone book that wasn't sorted? That'd be terrible. You'd be looking at every single page. Okay, so I'm just not going to write these, okay? All right. Basically just talking about, he walks through these in the class. I'm just not going to walk through them now. They'll take too long. Okay? Sorting an array. Sorting is very complex, and there's actually many different sorting routines. Okay? Some are quicker than others. The bubble sort's probably the fastest. When I was going to school, I actually had to write a program that did all the different types of sorts, and you had to see how long it took to do it. The bubble sort's pretty quick. Okay? Examples, we could sort our email. Do y'all sort your email when you get it in your inbox? Yeah, I always sort. What do you sort by?
I usually sort by name.
Sort by name? Okay. I sort by the receive date. In other words, with the newest at the top. But then what I do is, since I'm behind right now, so like say I got an email from Ravi. Okay? So it just came in. I'm sorting by dates. It just came in. But then if I'm going to answer it, then I click on it, but then I sort by name. So then I can answer all of the emails from Ravi at that time. So the closing, you can sort by multiple different things. Okay? You can sort by song. I went to the gym today. I sorted by artist, picked an artist, and picked an album from that artist. And I went jogging based on that. Okay? Sort by student ID. So there's all kinds of different things about sorting. Here's a selection sort. Okay? This is a very good one. Let's walk through it. It says, first expose the selection sort, and here's how it works. It says, we've got a for loop, starting at 0, going to the length. So that first part says, for I is equals 0, I is less than the length, I plus plus. So we're going to increment. It says, find the smallest value in the list. Okay? From where you're at to the bottom, swap it with the current one. So we're going to go through our list. We have 5, 10, -3, 20, and 2. That's what we start with, okay? So we go through the list, find the smallest value, put it at the top. So the -3 goes to the top. Okay? Everybody see that? Then we go through the list again and find, starting at position 2, and put the 2 at position 2. Then starting position 3, well, it's already a 5, so we're going to leave it there. Then we swap the 10 and the 20, then we're done. That's called the selection sort. It does work quite well, but it's not the best. Okay? Okay. There's a lot built into it, and if you go up on java.oracle.com, you can see it's basically array.sort, and it does it for you. It's quite simple, but But there's just a bunch of different methods. So we're not going to walk through doing them, but bubble sort's probably the best. We're just not going to walk through this. He does say something here called, it says put the sorting methods in a utility class. Okay. I've written a lot of different programs for different things. And one that I used a bunch was I actually wrote an online grading system similar to WebCT, D2L, eCollege. I wrote one years ago, way before they were out there. I wrote my own. And I needed to have, things left justified and right justified and centered. So I wrote a helper class that had all those different methods in it for, pad L for left, pad R or pad C. So I basically put it in there. What he's talking about here is you can make a utility class to just hold these kind of things. Once you start writing code out there, you're probably going to write something good someday that might have multiple uses. So put it in some sort of utility class, kind of like we import the scanner class. Well, you can import your utility class. Could be Ken's utility class. And we just bring it into everything. Okay? Alright, so that's pretty much what he's talking about here. Okay? So if you make a sort method for an instance method, then you'll be required to bring it each time. But if you import it, it actually does it quite easily for you. Okay? But with this one here, we would actually have to sort it. Okay? Now, the difference on this slide here from the top and the bottom, the top one's an instance. It's an instance method. Okay? So we have to create a new instance of the sort. So we make sort s equals new sort. Then we can do s.sort. So we're sorting the student IDs. Okay? Now if it was a class method, we don't actually have to instantiate the object. We would just call it sort.sort or whatever. You could call it ken.sort if it was the Ken class or something. So you can very easily call it, if it was a class method, it would be easier. Now here's the actual code for the selection sort, the one we looked at a couple slides ago. So it starts, then it creates J, then it says I is equal to 0, so we're starting at the top. Going all the way down. Then it says J is equal to the next smallest. Now next smallest is actually a method right here where it's going through the list from your current position to the end, just comparing them. It's just doing a comparison of each one. Okay? I'm not going to spend a lot of time going through these because it's not too critical that you know how to sort things, not required for your program. But just know that there's plenty of examples here, and using loops you can very easily figure out how to sort things. Okay? Alright. Here's a swap method. Okay? We're going to give it an array and then two integers. It creates a temporary, then it copies the array item into the temporary, then swaps and then copies it up. It's just another method he made for swapping. It's actually used in conjunction with this, isn't it? Should be here somewhere. Where's swap at? There's swap. Swap's right at the top at position 2. Okay? That's just his little driver program. Okay? Two-dimensional arrays. If you think of an array as like a row, and a two-dimensional array is like a row and a column. So what if we could have two? We could have multiple items, but the way you access them, rather than the array name square bracket 0, you would do array name square bracket 0 square bracket 0, then 0 and a 1 and a 0 and a 2 and a 1 and a 0 and a 1 and a 1 and a 1 and a 2. It's row and column. You always go row and column. So what is in 0 0? 8. What's in 0 1? Negative 2. And 0 2 would be 4. Then 1 0 would be 1. And then 1 1 would be 0. And 1 2 would be 5. So you can very easily use a two-dimensional array. And here's how you could declare them. You know how we declared an array last time? But we just had, I think it was string, we did a string. String square brackets equals, then we put it inside parentheses. But with a two-dimensional array, you just put the braces on the outside, then this will be the first dimension, this will be the second dimension. So he's actually declaring this array right here. So he's got 8, negative 2, and 4 right here. Then he's got 1, 0, and 5. If he wanted another one, he put a comma, then another one. Okay? So it's quite simple to do it that way, or you could do it this way. Here's his example here. Int square brackets. Now since it's two-dimensional, he has two sets of them. X is equal to new integer 2 comma 3. Okay? So he's going to have 2 rows and 3 columns. Okay? You don't have to create any two-dimensional arrays for your programs, but I'm just showing you that you can. Okay. When I took one of my program classes, we had to create a five-dimensional array. The whole point is so many people think of row and column, then they think with a three-dimensional, think of row, column, and then depth. And four-dimensional, you can, but five, sooner or later you get to the point where you can't draw it anymore. It really doesn't matter. You just put another bracket in there. That's all you got to do. Okay. And so this is more of just for information because you're not going to have to do it on your program. Okay. And he's showing you how they work. Okay. So you could very easily use a two-dimensional array to sort tables, to do all kinds of stuff with it. Okay. And here's his program to do it. Okay. He's all declaring the array. And he's searching through it. Okay, we're just going to skip over the rest of this because I'm not going to walk through the two-dimensional array. Okay. If you're interested in them, the examples do work in there, so you could go play with them. Okay. All right. Now we talked about arrays of strings. We had arrays of integers. We could have arrays of objects. You could have arrays of cats. You could have arrays of calendars. You could have arrays of whatever. So you want to keep track of the total sales of each sales and department store. Farm check or clerk array keeps track of the number of clerks, so you can have an array of clerks, an array of students, an array of whatever. Okay, do you have a question? I thought someone said something. Okay. All right, so it'd be very simple to keep track of it. So rather than can you imagine if I I got about I think I have 40 students enrolled in Java right now, even though only half a dozen of you show up. But if I had to have 40 separate variables, it would be terrible. But I could have students 0, students 1, students 2. Then I can keep track under one name. Then each of you could have a different index number, kind of like student ID kind of thing. All right. All right, and he's showing just how to fill the student array. Again, it's just for informational purposes here. Okay. There's his program to do it. Okay. He has lots of programs going through all this stuff. I'm just not going to walk through them in detail this time. Okay, so beware, to create an array of objects, you must instantiate the arrays with the new operator. This is kind of important. Okay, so here we're making clerks is equal to new sales clerk. Okay, basically what he's doing, he's making an array of clerks, but you need to instantiate them. Okay, and he should show it. No, he doesn't show it in there. Okay, actually, let me show you that. Actually, he did on the he did on the other slide. Hold on. Let me find it here real quick. Let me find where he instantiates them. Should be right. Okay, so up here at the top, number 3, we have sales clerks. Clerks equals new sales clerks. That's not an array. Where's this array? Hold on. Gotta find this array. There's his clerks array. What? Is it there? Where's he define this darn array at? There's no array there. Is there an array there? No. No array there. Oh, there it is at the top. Private sales clerks, clerks. So he has an array called clerks that's an array of sales clerks. Okay? But then down here it says clerk is equal to new sales clerk. So he really made it, but they haven't been initialized yet. He then actually, with each one, he should have done it in here somewhere. There it is. For each sales clerk right here, clerk index, so for each item, he needs to go in here and say it's equal to a new sales clerk. So if I made an array of cats, I would still have to go into each element in the array and instantiate it.
Well, first you went, was it clerk index filled elements, then clerk is clerk index.
So he's whichever one he's filling, he's actually instantiating that one.
Okay.
Yeah, because he was going through each one there. So you just have to do it for each one. If you don't, it won't work. It'll say item has not been initialized yet. Okay? That's all you have to do. Okay? All right, might think that since the above specifies the max clerks, automatically does it. It says the JVM only instantiate the array object, and each array holds null. So if they're an object, you have to instantiate them if you want all the other components of it. Okay? Now, ArrayList is the part you need to work on your next program with. Okay? All right, let me Hold on one second. Let me see something here. Is there a way to pause this? Well, I don't know how to pause it, but okay. But we're going to walk through your program at another time. Totally. We're going to talk about ArrayList first. Okay. Now, does anyone know what a problem is with an array? Can't think of a problem. So I make an array of students. Okay. So how many?
Public information, that's a big change anytime, maybe.
Well, yeah, but that's not really where I'm going with it. How about if, okay, I'm going to make an array to hold all the students in my class. How big should I make the array?
However many students you have.
Oh, I see. It's-
I'm going to make it for 20.
You have to define it. Can you not go back and change it?
You can't. An array is stuck.
Okay, so that's the
If you make an array to hold 20, you can hold 20 and that's it. What if I got 40? It ain't going to fit. So obviously I need to make it for 40. But then what if I only have 20? And then I got 20 leftovers. Okay? Point with an array, you cannot redeclare an array. You can't. Once you declare it, say like I'm going to make an array to hold my students. So it'd be 20 would be a good number, maybe 40, maybe 50, maybe 75. I've had as much as 55 students in a class before. So how big should I make the array? And the point is, once it's made, it's made. That's it. Okay? An array list, it provides the basic functionality that comes with an arrays plus added functionality. Okay? The basic functionality stores an ordered collection of items just like an array does. You access them via the index. But it has added functionality. It can grow and shrink dynamically.
So what would be, I guess, should you always use an array list? Because
No.
what reason would you use an array
Well, with an array,
Yes, if you don't know.
if you're not sure how big it's going to be, yeah, use an array list. Okay. But arrays are going to be faster because I can instantly say, clear me 500 of them, done. With an array list, I have to add. I got to keep adding all 500 of them. With an array, I can just say, give me 500 of them, done. With an array list, I create one, then I add an element to it. Then I add another element, and another. I can keep adding as much as I want, and I can also remove. I can also search through it, which is nice. So it's dynamic. It can grow. It can shrink. Okay, I can insert and delete even at specific locations. The problem with an array, say I make my array to hold 20 students, and I put you all in there. Then all of a sudden, someone with the name of Clark enrolls. Oops, I got a Banley and a Denson. Darn it, it needs to go right between you two. So how am I going to stick him in there? Either I'm going to have to shift you all down by one, or I'm going to stick him at the end. Now he's out of order. Okay? So in an array list, I can go right between you and stick Clark right in between you two. Okay? So dynamically insert and delete at specific locations. Okay? It's defined in the ArrayList class, the import.java.util.ArrayList, just like we did java.util.scanner, all that stuff. Okay? To initialize it, it says ArrayList, then the element type, then the variable name, then is equal to new ArrayList element type. Kind of like we did array, an integer array, so on. So you tell what type. And here's our example. ArrayList student. So what the array is called students with an S. What type of array list is it? Oh, it's a student array. And these rectangular or whatever, less than greater than are needed. They are not. You do put them in there.
They're not an example.
Right, they're not an example. That's exactly how you do it. So down there, position 3, we say ArrayList students equals new ArrayList student. So we're creating an array list called students with an S, lowercase s. What type of it? Well, it's a student array list. Okay. Now at the bottom, there's an example of a regular student array. So what's the difference between these two? Well, at position 3, we really don't have any space in it yet. It really doesn't have anything there yet. It's declared, just doesn't have anything to do with it yet. Number 4, well, it's declared and even has 100 elements in it. Okay? All right. Okay, what are the syntax differences? Well, the angle brackets are needed. Must be a class name, not a primitive. Okay? It says, do not specify the number of elements because there are no elements. It adds and grows. It shrinks. Okay? Okay? And with it, we call add or remove. So we say our ArrayList variable, that could be our students dot add, and we give it an item, what we're going to put in there. Okay. On the program you can write, I'll give you examples of what to put in there. So the item added must be the same type as the declaration. So if I'm going to add something into my students array list, obviously it must be a student. I can't put a dog in there. Wouldn't work out. Okay? So I wrote a code fragment that would do that. So I could say, so the code fragment for this, we could have array list colors, color equals a new array list colors. Then to add them, we'd say colors.add red, colors.add green, so on and so forth. Actually, it could be an array list of strings as well. It could be either way. Okay? Kind of with me? We're going to walk through your program the next class period. What?
Could you repeat what we have? You said on the one before.
All right, right here. This is an array list of students.
Well, we changed it to colors.
Yeah, well, actually, we could do with strings. It'll be easier. We could say array list string and color instead of students, right? So it would be array list string colors equals new string. Okay. Then over here it would be colors dot add red, colors dot add green, colors dot add blue. Okay. Easy enough. All right. All right, now APIs, again, I'm going to walk through your program with you. I think I currently have it set to be due Monday, is that right? I'll move it back one Monday because we're going to talk about it on Monday. Okay? But you could start working on it. Okay? So,
You said you'll move it back or what?
Forward.
Forward, okay.
the other way.
It won't be due this Monday.
It won't be due this Monday. Is that better?
2 weeks.
All right. So the Java API, what an API does, it allows us to use other people. It's kind of like the scanner. Did we use it? Yeah. Did we write it? No. We just used it. Okay. APIs are written so we could use it. The math.pal, the square root. Remember we walked through examples of square root. Did we write those? No. We just used them. So the API allows us to do that. Allows us to use pre-built-in methods. Okay. All right. All right. Now let's. Here's some of the stuff you can do with this. With standard arrays, you use square brackets. With these, you don't. Instead, use the get method. Now, remember with a regular array, use the array name, square brackets, and the index number, like 0, 1, or 2. With an array list, you use the get method. So it would be colors.get 0. Colors.get 1. It will return them that way. Okay? He just doesn't have an example in it. Again, the program I got you working on does have one. Okay? So the index parameter is the index of the item. Again, starting at 0, the second one's 1, so on and so forth. That didn't change. Okay? If it doesn't exist, it's going to fail. Okay? If it's valid, you get the element at the position. Okay? Which he really doesn't give us. Hey, he doesn't give us any examples of those. Okay? Now, there's no E is the return type for it. What he's showing us here is the API or the method call header, so we know what it is. So the get method here will return the element at index of type E, whatever type E happens to be. Okay, the E stands for the element, represents the data type, which we just mentioned. Okay. See if he has an example. He doesn't have any examples in there. I thought he had some examples. Okay. The set method allows you to set something at a current position, so you can actually overwrite a position. I could say at element 0, I could say colors.set 0, purple. Then whatever is at position 0 is now purple. Okay. So the index parameter specifies the position, okay, and then the element is what you're actually giving it. Okay. All right. Aha, here's one. Good. I thought there was an example somewhere. All right, so we have a string called mixed color. Then we have an array list called colors, just the one we walked through. So there's our array list string colors. So we have an array list. What's the name of the array list? Colors. What type of array list is it? It's a string array. It's equal to a new array list of type string. Then we do colors.add red, colors.add green, colors.add blue. How many elements we got now? 3. Then mixed color equals colors.get 0, so it's going to retrieve red, plus colors.get1 plus colors. No. Okay. Colors.get0 plus colors.get1. So what does mixed color, what value does it have? Anybody? Mixed color is a string. It's equal to colors.get0 plus colors.get1. So what does mixed color equal? What's color.get0? Red. Colors.get0 return red. Then we have a plus, but it's really a string concatenation character. Then colors.get1 will return green. So mixed color is equal to red, green. The string REDGREEN. That's all it is.
So it's gonna be blue-green, color set blue-green.
Well, then color set 2, what's position 2?
Blue.
So at position 2, set mixed color. So position 2 now contains red-green. So position 0 is still red, position 1 is still green, position 2 was blue, now it's red-green. Everybody see that? So what we did is we just replaced 2. Alright, we can also add elements to it. If we just say add, it adds to the end of it. If we just say add, like here colors.add, it adds it to the end. If I said colors.add black, it puts black at the end. But I can also do add specifying an index, so I can say colors.add2. What it'll do is actually move them down. Okay? Starting position index, shift the original elements to a higher position. So if I said colors.add1 black, what would happen? So forget mixed colors. Just go with the red, green, blue. Okay? So 0 is red, 1's green, 2's blue. If I said colors.add 1, comma black, what would my final result be?
The red,
Green,
black, green, blue.
Red, black, green, blue. Because what it'll do is that at position 1, which is currently green, I'm going to put black. But what's currently at 1 and below gets shifted down by 1. So it just cut in line is what it did.
So that makes green 2 and blue
Right.
3.
Then green would become 2, blue would become 3. So with the
and
add...
we already set 2 to be red green.
Right. Well, I'm just saying we didn't...
I do have a question.
Yes. Yeah.
With the mix with the array list,
Right.
here you're declaring it as a string,
Right.
but now that won't be able to hold more than one value in that array.
Right. It could only...
Okay, so that's the disadvantage of using the array list, is you can only have one value being stored.
Well, actually, we have 3 values. We have a red, green, and blue.
Different types of values. So I'm saying.
Oh, right.
you
But
know
even an
what?
array, we can have an array of integers that only can hold integers.
Okay.
But
So-
I could have an array list of cats.
Right.
I could have an array list of whatever I feel like. In the program y'all got to work on, you get an array list of mice. So it can't be an integer. It has to be an object reference type. So, all right.
I was just thinking of my head like examples, like if you're doing an array list of different values for like different types of values, like strings and integers, that just, we can't do that.
Actually, we could have strings. But actually there is a way. How could I make an array list of integers? Anybody?
No, string
No,
and
what I'm
integer.
saying, string and integer.
Oh, no, string and
Okay.
I could make a new object type called Ken that contains a string and an integer.
Okay, so as object variables, you can have more than one type of.
Right, I can make a new class called the Bandly, and the data members of that class are an integer and a string. But remember this comment back somewhere in here that said we're array lists have to store reference types, cannot store primitives? But how could I make an array list of integers? There's a way. Remember the wrapper class?
You have to,
Remember the integer wrapper class? We could actually make an array list of integers with a big I, because that's a wrapper class that contains it. So I could do that. That way I could do it. Okay? All right. So add, we can add a specific index. Clear wipes it out totally. If I need to take my array list, wipe it out, rather than go and remove, I could do clear, they're all gone. Okay? I could do index of, searches for a first occurrence, just like the regular index of does. I could do is empty. Is my array list empty? Could also do remove. I could remove one. It says remove the elements at the specified index and shifts everything up. So back to my example here. So if I did colors.remove 1, what would happen? What would my final result be?
Red, blue.
Red, blue. Exactly. So removes the element specific index, shift everything's up, and returns the removed element. So remove actually returns the result. So I'm removing it and grabbing it. Okay? I could also do size to see how big it is. I could do colors that size, and it could tell me 3 or 2 or whatever. All right, and yeah, the same slide. All right. Here's an ArrayList program. Okay. Let me see something real quick here. I don't know how many there are. Okay, yeah, we got more. Okay. I'm not going to walk through his, but, well, actually we can real quick. He creates an array of typed strings called tribe. He adds Richard, Jerry, Colby, Amber, and Rupert. Then the loser index. So what is he doing there? Well, he's randomly picking a number and kicking them off. I guess he's playing Survivor. Yeah, it is called Survivor. Duh. So he randomly picks a number. Then the loser is equal to tribe.remove at that index number. So he randomly picked a number between 0, 1, and 5. Actually between 0 and 4. Then he removed him. Then he says, sorry, tribe has spoken, you must leave immediately. Easy enough. There's an array list. We could very easily add more people to it too. Alright. Actually, say we've got 5 elements there. Richard, Jerry, Colby, Amber, and Rupert. Could I just add more people on there quite easily?
Yeah.
Sure. But how would I make this program? But the way this program is written right now, it's only going to retrieve a random number based on 5 people. See that?
Yeah.
So how do I make it so no matter how many I add, it'll automatically work?
You would have to do math.random parentheses times.
Something there help us? Bottom? Size. So we can do math.random parentheses times tribe.size. That way, however big our array list is, it'll automatically do it between those. So I wouldn't have to add the name and update the other part. Because the problem with stuff like this, you'll probably forget to change the 5. You'll add 5 more people or 3 more people, and like, how the heck am I ever getting called? So, all right, printing, concatenating. It says if you attempt to print or concatenate an array list, returns a comma-separated value surrounded by square brackets. That's what you get. Okay, that's what it looks like. And again, you don't have to do that, so don't worry about it. You need to store primitives. You can't do it, but you can use the wrapper classes. This is what I mentioned. You can do that. You can use the integer wrapper class. The advent of 5, the wrapping up process is done automatically behind the scenes. Okay, takes care of it for us. Okay. Okay, let's see. Here's his program. So instead of a double with a small d, he's using a double with a big D. Just like I said, integer with a big I. Okay. Here's his stock average program. Okay. I'm not going to walk through it. Okay, here's another one. Simply use anonymous objects in a for loop. He's creating some bears. Okay. So he's adding a new bear that's an Acme bear. It's a brown teddy. Yay. It's an anonymous object. Okay, it's instantiated, but it's not stored in a variable. What he's talking about here, he's basically adding a new element. But rather than creating a whole nother variable and adding it, he's just adding the value into it. So instead of creating a new bear, he's just doing it. I don't know what else to tell you. But it didn't say, bear 2, whatever bear 2 is equal to new bear. He just says new bear. And that results of that will actually be stored in this new bear array list. It's not critical, you really understand that, but it's how it works. See? Here's his array list of bears. Okay, he's adding a bear. Okay? Don't worry about it if you have no clue what I just said there. Okay? It's just, it can be done. I said he has a lot of examples in here. Okay? Whole bunches. Okay. There he's talking about that again. Okay, this is the bearer program uses specific examples, so you can use them. Okay. Now, here's something else. Your next program requires this, or actually uses it. I actually wrote this part for you. It says the for each loop. Okay. It says read this as for each bear in bears. So instead of saying, int I equals 0, I is bears dot size, I plus plus, whatever. What this is saying is for each bear in the bears array list, do something. Display them. It's just a shorter way of writing it. And this program, I actually give you that already written in for you. Anyone look at the program yet? A couple of you? Yeah. You'll see I actually did that part for you, just so you'll get an idea of how it works. Okay? All right, and there's the example. That and that are the same. Pretty much. Okay? The for each implementation is preferred because it's shorter. So if you needed a for loop that's going to do the same thing, it doesn't have to be an ArrayList, by the way. You can do this for any kind of thing. But if you got a for loop that's going to do it for each item, just use the for each loop. It's easier. If you do the same thing for every item in the array, do it. All right. It says be aware you can use the for each loops for more than just ArrayList. You also use them for standard arrays. Okay. This is the same for each p in primes. Print them. So we have an array of primes, 1, 2, 3, 5, 7, and 11. So for each p, in other words, integer p, in, the colon means in, primes, print them out. So it's easier than saying for I is equal to 0, I is less than primes dot length, I plus plus, then print, primes dot whatever. So what happens for each element in primes, it stores it in the value p, it does something with it. In this case, it's printing it out. Okay? Alright, new Java 5. This is for each is new. So it won't work with old stuff, but as far as I know, most of our stuff, it works. I never had an issue. That's the one you just showed us. It's the same one. Oh well. Alright. It says new Java 5 won't work on older computers or older compilers, so just be careful with it. You can write it without it, but it's just easier doing that. Okay? Alright, now let's talk about some of the benefits. Benefits of an array list over standard array. It's easy to increase the size of an array list, just call add. Okay? It's easier to insert or remove, just add or remove, and automatically sticks them in the spot or removes them from the spot. A normal array, okay, it says use the square brackets, which is easier. You don't need to set or get. You can just say element 0. Okay? And it's more efficient when storing primitive data types. So if you're going to have an array that's going to hold 100, just use a regular array. But if you're not totally sure, it could be an array of objects or something, use an array list. Okay. Alright, last slide. See if we can't get these. The book uses the acronym ANSI for a mnemonic device. What does ANSI stand for? A new sorting yield. Arrays never say yield. Arrays no strings yes. Arrays no strings yes. Yes, that's correct. Well, actually, what did that refer to? The parentheses around the length. Remember that? Very good. All right, which of the following is syntactically correct Java example of accessing an element of a two-element array?
A.
Got a B, we got an A. Anyone want to go for C? It's A. All right, I think one more. In the book, the example is given for a three-dimensional array, keeping track of rainfall. I don't remember. I went through it. Rainfall, airline travel time. Does anyone remember? I don't remember. I got to take this real quick. Hold on. This is the last. Anyway. All right.